Hello all, and welcome to the 8th tutorial of PSYC 201W, where we'll be learning how to analyze your data so you can report on it within the results section of your final research paper. This tutorial is a lengthy one, but there are many tips and tricks for analyzing data for the purpose of this class contained within. So please don't skip anything, especially if you are unfamiliar with formulas in Excel like I was when I was in your shoes. This will be a lifesaver for you then if you are one of those people. I don't need to give any feedback to start the tutorial off this week, but I wanted to quickly clarify a couple points that many students seem to be confused about. I received a couple questions over the past week about why I gave such extensive feedback on your research proposals and if students need to resubmit the proposals with the feedback addressed in any way to me right now. So no, you don't need to do that, but this is why I devoted the time to giving you all that feedback. So here on the slide, you can see the proper structure of a research report. You have your four main sections: introduction, methods, results, and discussion. And you see the subsections that your papers should be split into as well. However, for a research proposal, you don't write it all because you haven't done the study yet. You're proposing your project, so you're describing in detail what you will do, if you can. And I say that because proposals are often submitted for grant applications, for master's or PhD, theses or dissertations, etc. And if you actually get to do the research is contingent on whether the proposal is approved or not. So in the proposal, you only write the full introduction, culminating in a statement of the research question and hypothesis and rationale for it, and then your full method section, so readers can see exactly how you're proposing to conduct your study. Therefore, when you write your proposal, which you guys already have, you are only writing the sections that are indicated right there in blue on the slide. When writing your final report, you include all four sections. Therefore, you still will be submitting everything you wrote for your proposal in your final report when you submit it in August, but you will have added on to the paper, and specifically will have added the results and discussion sections. So that's why I gave all that feedback on your first two sections, your intro and your methods, because you'll be resubmitting them again in August within your final report as part of it, but not until that is due in August, like I said. So also, I will say here that you will be able to draw heavily off your introduction and your method sections that you already have written, but you should not just submit them as they are right now with your report and not give them another thought. At the very least, even if they are stellar, you should be editing your method section so it's now reading in past tense, as I discussed last week. Of course, I would strongly recommend that you address the revisions I gave, as I will be looking back at them while marking your final report. And if you changed your hypothesis at all, either because we discussed it privately in a meeting, or if you decided to independently, there's a good chance you'll need to rewrite a bit of your intro to align it better with your new hypothesis and to give adequate rationale for your new hypothesis. As always, please come see me if any of this doesn't make sense to you or you have any further questions about it. And on a last quick note, I wanted to give a template for you to look back on when formatting your final report. This is the order that everything you're including should go in. You see I've condensed each of the main text sections, so they're not split into subsections. That doesn't mean you shouldn't include everything that's in them. After the body of the written paper, the references should then immediately follow. After that is where you place your table or your figure. You only need one, and I'll talk about formatting that a lot more today. But anyways, it does not go in text in your results section. That's a mistake a lot of people make. It goes right after your references on a separate Word document page at the very end. If you want to go over and above and it makes sense for your data, you may include both a figure and a table, and tables always go first in that situation. And then appendices go very last. So we'll start today's tutorial content with the most basic introduction to statistics in psychology. Statistics help us make sense of groups of data points and help us describe our data. We can use the raw data we collect during our studies and use our knowledge of statistics to draw inferences beyond what we just can plainly see in our data. Unlike regular math, statistics involves both math and interpretation, so we go beyond what our numbers say. As I'm sure many of you will be very glad to hear, this is not a stats class, so we will keep it very basic in this tutorial. However, for those who plan to continue in psychology, there is more statistics in your future. There is PSYC 210, which is mandatory for a regular psych bachelor's degree, and possibly there might also be PSYC 301 in your future, which is not mandatory but needed for honors. So for example, try and make sense of this table. There aren't even that many numbers in the general scheme of things. It's not a data set of 100 or 200 people, but it is confusing, right? There's test scores, hours spent studying, numbers for each. Where do we even start? So as you just saw, raw data is unintelligible. Without statistics to help us, it's pretty much meaningless. Individual data points are also pretty meaningless. What does it really mean when someone studied 3 hours and scored a 15? Is that good or bad? 15 out of what? So individual data points need to be understood relative to the larger data set, which in this case would allow us to understand what 15 really means after 3 hours of studying. Statistics is all about making sense of this larger data set, which allows us to say something about the whole group of data points and individual data points after that. There are two general types of statistics, descriptive and inferential statistics. Descriptive statistics is really just that, describing your data, and it tells the reader what it is, just the facts, and it describes the nature of your data. You're only describing what's there, you're not making any other conclusions or inferences or kind of going beyond just the plain numbers in any way. This is mostly what you'll be doing for your research report. Inferential statistics uses the data to draw conclusions beyond the data, which is what statistics is really all about and what is used most in published journal articles. It requires sets of assumptions, which you will learn about in future classes, not this one, and it also involves interpretation, which we will be doing just a little bit of. So let's move on to some basic descriptive statistics now, which you may already know, but should review before you embark on writing your results section. So we'll talk about measures of central tendency first. Basically, these measures ask, where's the middle point of the data? What data points are most common? One of the most basic questions is about where the center of our data is. Measures of central tendency include the mean or average. You've probably heard it referred to as the average most commonly, but we do say the mean in psychology and in research writing, the median, and the mode. So I assume that we're all quite familiar with averages. You've likely discussed average age across people, average score on various things like test scores, average yearly earning or income, average GPA, et cetera, in classes or at other times in your life. The mean of a data set is obtained when you take the sum of all the scores, so you add them all together, and then you divide that sum by the number of scores or the number of data points there are in the data set. The mean tells us about the center of our data in a way. However, the mean is very sensitive to extreme scores. Very high or very low scores will drag the mean up or down in a way that doesn't fairly represent the overall data. These outliers are extreme scores and they can affect means. So for example, let's say 90% of a class scored below 60 on an exam out of 100, but 10% scored very close to 100. So if we just take the average of all of these scores, it might look pretty good due to the 10% high scores that are kind of dragging it up. It could be in the high 70s, but that mean alone doesn't really capture how difficult the test really was for most people, 90% of them, and how many people scored quite poorly on it. So you might ask now, what is the strict definition of an outlier? It depends, and it is determined relative to the data it occurs in. So you'd need to have a sense of the minimum and maximum possible scores to see where outliers could even fall. And furthermore, what's an outlier also depends on where most of the data is clustered. So it's somewhat subjective, and the best way to see if you have an outlier or two is really just to scan through your entire data set and try and see if there are any really low or really high scores. So here's a visual example, as I find that these are really helpful when talking about statistical concepts. Thanks to Lee Vargan, one of the other TAs, for allowing the use of some of these illustrations. So going back to the previous example, you can see that the scores on the exam illustrated here are stacking up how I described. So most are around the 40 to 60 mark range, with some even lower than that. But then there's this small cluster at the very right-hand side, all around the 90 to 100 mark range. So when the mean is calculated, though, it will look like the arc and then the line that's through the data, and it will fall somewhere around the 70 to 80 mark range, which is where that big line is. So now looking at the visual graph of the data, it's all well and fine, but what if you were to just report the mean value without this visual representation of it to someone else? A reader wouldn't have any understanding that the test was actually quite hard and most people did pretty poorly. And even more interestingly, a mark in the 70 or 80% range would come across as one of the most common scores to a reader that just reads it as the mean, yet no student actually received that mark at all. It was on either side of it. So next we have the median, which is the 50% mark in the data. This is a single point at which 50% of the data falls above and 50% of the data falls below. Why would you choose to use a median instead of a mean? The main reason, as you can probably guess, is outliers, and if there are big inequalities in the data at either end of the spectrum of possible scores. So examples of this include real estate values in the lower mainland, which are horrible, lifespan, and infant mortality rates. However, I would encourage you to report both the mean and the median of your data in your results section. So let's take rent in the lower mainland as a visual example of a median. Say that most of the data points stack up to in the middle to low end of the scale, as you can see, but there is a big bunch of data at the very top as well. Of course, this bunch will skew the mean to be an unfairly high representation of the true common score of the data. But the median here would fall at a much lower point in the data, as it would show where the middle mark in terms of number of scores are. So 50% pay above the median rent dollar value and 50% pay below the median rent dollar value. So in this way, the median is impervious to outliers, as it isn't influenced by the actual value of each data point. It's only influenced by the number of data points in the set. Lastly, the mode is the most commonly occurring score in a data set. That's it, nothing fancier than that. It is less common that researchers are really interested in the mode, but let's say you're doing a survey about customer satisfaction and you want to know the most common complaint customers have. Then you're looking at the mode. And then we have percentages, which are also a helpful way to describe certain kinds of data. So 50% of respondents indicated that they support candidate X. That's a percentage. And percentages are quite easy to calculate. It's just the subset that you're interested in, the subgroup, the portion of the data that endorses a certain response, anything like that, divided by the total number of all your participants, and then multiply that by 100. So say you have 100 people, 57 of which support a certain political candidate, 57 divided by 100 equals 0.57 times 100 is 57%. Of course, it's a very easy example, but the math is the same for any other values. So additionally to central tendency, we're also interested as researchers in the spread of the data. You want to know how spread out your data is. You want to know how your data clusters around the mean. These are questions about the variation in your data and how much spread there is. And it's all about the variation of all of your data, the scores, the points, and variation is essential to statistics as well, and you will be reporting some measures of spread or variation too. So to illustrate what I mean in the most simple terms, you can have a narrow distribution, which you see at the top of the illustration there. In it, data is very tightly clustered around the mean. So the pointy peak there means that almost all of your individual scores are stacking up right around the mean, super close to it, and then there are only a couple kind of trailing outliers at either end. And then the lower picture there is a wide distribution. So in it, there is a mean still, but the peak isn't very pointed. The data are spread out across a wide range of values, and that is where it is more widely dispersed. So additionally to central tendency, we do want to know the spread of the data, as I mentioned before. One of the simplest measures of spread is range. Here, it's the difference between the highest and lowest value in the data set. It shows the range of scores your data falls across. When you get further along in statistics and measurement issues in psychological research, you'll learn about the issue of range restriction, which is when your range is very small. So say maybe your data only falls across scores 1 to 5, so there's only a 4-point range, and therefore there is not enough variability in your data. So say if your independent variable influences a change in your dependent variable measured on a 4-point range, it's harder to detect that change than if your data falls from say 0 to 100. And is measured, the dependent variable is measured in many smaller increments. This is getting somewhat complex though, so if you want to talk about things like this, definitely come see me in office hours. The range is informed by the minimum and the maximum values, which you should also report in your results section along with the range. And of course, those are very easy to identify. Too low of a maximum value and too high of a minimum value lead to ceiling and floor effects respectively. And this is when your data bunches up around the minimum value or the maximum value because it wants to spread out further in that direction. Hopefully that makes sense, but it's restricted by the range of possible scores. So there's no score beyond the minimum or the maximum value, so the data can't spread out more, for lack of a better term. And finally, there is the standard deviation, which captures the amount of dispersion in your data. This value is measured, measuring how close your data clusters around your mean. The standard deviation is the most complex statistical concept we'll discuss today. The basic idea is that the standard deviation is the average degree of deviation away from the mean present in your data. In other words, the standard deviation takes the average distance that each score is away from the mean. So do you see the black line there with the little dots on it? say that the blue ones are actual data points and the orange one is the mean of them all. So now these blue lines that you'll just see appearing right here are the individual distances that each individual data point is from the mean of the whole data set, the orange dot. So your standard deviation calculates the average of all of these blue lines, the distances, and tells you in a single value how spread out your data is on average in a helpful metric, standard deviations. So you can calculate one standard deviation value for your entire data set, which you will need to do and report in your results, but you can also take a single score and figure out how many standard deviations it is away from the mean. So you'll see the formula for calculating standard deviation here on the right side of the slide, but since many of you have 100+ data points, it would take you quite some time to calculate it all by hand. So watch for an Excel formula shortcut later in the tutorial, which I highly recommend you use instead. Next, let's talk a bit more about data set distributions. Researchers are always interested in the shape our data takes for more complicated reasons down the road, but you will still need to know your data's shape for your final report. When we collect data, our data is distributed across all the possible values of our measurement tools. So for example, if your dependent variable is an exam that participants are taking that they can score 0 to 100 on, 0 to 100 is all your possible values of measurement. You've probably all seen bell curves. This is a very common visual depiction of a distribution of data. So you can see the typical bell curve distribution in the top left corner there. This is also called a normal distribution. Your data can really be distributed any possible way, but here are a few more common general shapes that you can identify. You can have a bimodal distribution, which is in the top right corner, with two peaks, which show that there are two different modes, most common values, like we talked about. Can you guess where the mean would fall in the bimodal distribution data set? So if you said right in the middle of the two peaks, you would be correct. On the bottom left is a positively skewed distribution. This is tricky to remember, but it is considered positively skewed if the tail end, not the peak, runs towards the larger positive values. I know that this was the opposite of what I expected when I first learned this, so try and memorize this quirk early because it'll help you later down the road, especially in 210. Conversely, your data falls in a negatively skewed distribution if the tail runs towards the smaller values or negative values, and most of the values are up towards the larger values, as seen in the bottom right-hand corner of the data set. Or sorry, of the slide. So plotting the distribution of our data is helpful because it lets us identify trends and characteristics in the data. You don't need to hand in a distribution of your data, but if you're familiar with a way in which to generate one, it would be a good idea to do so once you have your simulated data. Looking at this example distribution of USA income distribution, I'm saying that word a lot, you can see that it is negatively skewed. And because of this, notice that the mean or average is $63,000 roughly right there circled. And it's higher than the median, which is $46,000 due to the outliers at the top that are dragging the mean up higher. And here's another more detailed picture of a normal distribution. A normal distribution is unique. We can't just say any distribution that looks like it has one peak and is centered in the middle of the scale is just a normal distribution. Specifically, in a normal distribution, the mean, the median, and the mode are all the exact same number. It's not skewed in either direction, and it's unimodal. Further, exactly 68% of all data points fall within plus or minus 1 standard deviation. In this picture, it's from 120 to 180. And 95% of all scores fall within 2 standard deviations, that's 90 to 210, and 99.7% of scores fall within 3 standard deviations, which is 60 to 240 on the picture there. So next we'll do a quick recap of the scales of measurement, which I hope you've been introduced to before to give further context to analyzing your data. There are 4 types of scales of measurement: nominal, ordinal, interval, and ratio. As we go through the types, think, what will your independent variable and dependent variable be measured on? So in nominal scales, numbers are only used as labels. They don't really mean anything. Positions are marked by name or category, not numbers. If numbers are assigned to categories, they are completely arbitrary. So the numbers cannot be interpreted as representing any intrinsic order. So 2 different values on a nominal scale are just simply different. The values are qualitative data. Examples of nominal scales include sex, gender, eye color, ethnicity, etc. So you can't organize any of the categories of these variables in any one particular way that makes sense, like ascending or descending. All categories are just different. And these nominal scales or data on a nominal scale is often represented visually in bar graphs. So you can see the graphs like car colors and type of music, favorite type of music on the side of the slide there. Ask yourself, is my scale of measurement nominal? Well, some of you are not truly measuring your independent variable. If you're conducting a true experiment, you're manipulating it, you will have different levels or conditions of your IV. And when I generate data for you, these will be represented nominally. So this means I will assign a number arbitrarily to each condition, likely 0 and 1 if you have 2 conditions, or 0, 1, and 2 if you have 3 conditions. And that will indicate what condition each participant or your data cells, that would be participants if you were really doing your study, was in. And if you have a nominal dependent variable, which is possible, you are looking at the frequency of subjects who fall into each category. So an outcome such as a dependent variable of commits violence versus doesn't commit violence is an example of a nominal dependent variable. For this type of dependent variable data, you would describe it by listing the proportions or percentages of subjects falling into each category. In ordinal scales, positions have an inherent order, so the order does mean something here. See the examples on the side of the slide, like a random scale of chili pepper hotness or your position in a Mario Kart race. 2 different values on an ordinal scale are different in a particular direction, so they contain information about relative order. One value is greater than or less than another, although the size of the difference is not specified, which is integral to the data being classified as ordinal. If the size of the difference between values is specified, it's not ordinal. Examples of this type of scale include letter grades like A, B, C, and D, and sibling birth order. If you have an ordinal dependent variable, you would most likely report the median. You could calculate percentiles, but we won't be going over how to do that, and that isn't expected. I doubt many of you will have ordinal scales for your dependent variable or independent variable anyways. But please see me if you do and you have further questions about it. Next, in interval scales, there is inherent order like an ordinal, but the intervals between the positions are of equal size. A difference in 1 unit has the same meaning for all values of the variable. This type of scale provides information about both the direction and the size of the differences between 2 values. Examples of interval scales include time of day and hours, calendar days of the month or year, temperature in degrees Celsius, and the majority of the rating scales used in self-report measures. So it's likely that many of you and all of you that are using a self-report questionnaire will be measuring your dependent variables on an interval scale, and maybe even your independent variables as well, if it's a correlational study. Here you would report all measures of central tendency, the mean, the median, the mode, although the mean is the default measure, but please include all of them for the purpose of this course. Finally, we have ratio scales. These are very similar to interval scales, but the scale contains a true zero value. This allows us to compare scores as ratios. So for example, A is twice as tall as B. Many scales that you may think are ratio are actually interval, but a couple examples of true ratio scales include height, age, response time, for example, minutes or seconds, and speed in kilometers or miles per hour. If your dependent variable is ratio, you would report measures of central tendency, just like for interval scales, mean, median, mode, etc. Next, we'll discuss visual data presentation. I know this is a long tutorial, guys, but bear with me. We'll get through it. We'll go over tables and figures and how to create them in this section. Tables and figures can be a great way to communicate the patterns you have identified in your data, if you use them carefully and intentionally. What's the difference between the two? Tables are structured grids for presenting numerical data, while figures are visual presentations of data using graphs or plots. You see tables more frequently in psychology publications, but you do see figures somewhat often too. Why did I say that they can be a good way of communicating results? Often they aren't used well, and it just makes things even more confusing for the reader trying to decipher what they're saying. Tables and figures are being used well when they aren't redundant with what's in the text. So that means that you don't write your mean and standard deviation in the text of your results and then present it in a table as well. You should do one or the other, and it will depend on your specific project what it makes most sense to do. Your tables and figures should convey only essential information and be presented neatly. This also means they are easy to read and understand and are well designed and organized. In a figure, the independent variable is always presented on the horizontal x-axis, and the dependent variable is presented on the vertical y-axis. So let's talk about tables first, as they are commonly used in publications to display data, and it's likely quite a few of you will be using a table. The American Psychological Association describes tables as follows. Tables are efficient, enabling the researcher to present a large amount of data in a small amount of space. Tables usually show exact numerical values, and the data are arranged in an orderly display of columns and rows. So after deciding which data to present, you should consider that A, rounded off values may display patterns more clearly than precise values. This means that you maybe shouldn't include decimal places, it depends. And B, column and row averages can provide a visual focus that allows the reader to inspect the data more easily. So how do you present and refer to a table? In the body text of your paper, you refer to your table directly by writing table 1 and tell the reader what to look for. For example, as shown in table 1, the mean length of time for completion was greater for those subjects who did not receive training than for those subjects who did receive training. You do not write the table above or below because it won't be, more on that later, or the table on page 6. You should give any tables you include a brief but clear explanatory title. For example, mean number of correct responses as a function of mood. The title is at the top of the table, as you can see below when looking at the example. You number all tables sequentially and keep headings brief and clear. You should limit the number of rules, horizontal lines in a table, and rarely, if ever, use vertical lines. So this is an aspect of formatting tables in APA, and as you can see on the example, there are a couple lines going across, but none going down except for the borders. Also be sure to use generous spacing between columns and rows and strict alignment. Here's another example of a table, a simpler one that your tables could look very similar to. See how table 1 is at the very top, then the name of the table comes after, right underneath that. All lines are running horizontally, and this author has presented the results of their true experiment quite well. You have each of their 2 independent variable stimulus conditions, words and non-words, at the top of each column on the right-hand side there, and then their second independent variable, speed of presentation, is in the third leftmost column, listed to the left there. The dependent variable is the number of words recognized, and the mean of each of the 4 conditions is presented in each corresponding cell. So if you're wondering how I got 4 conditions, it's because they have 2 independent variables with 2 conditions each, and then you cross these numbers to get the total number of conditions. Next, we have line graphs, which are used to show the relation between 2 or more variables. They are particularly useful for illustrating results in factorial designs when there are 2 or more independent variables, which is not the case for most, if not all of you, so it's unlikely that you would use this format, but they are great to know about for future coursework. If you are making a line graph, make sure that the lines are smooth and sharp. The unit of measurement is indicated by the axis label. Legends, if applicable, are contained within the borders of the graph. They're not messy and kind of going out of it. And symbols are easy to differentiate. So here's an example of a line graph. So which quartile of the alphabet your last name falls into is the independent variable here. As said on the description at the bottom, and response time is the dependent variable seen along the y-axis there. There is one line shown, kind of trending downwards, but you can also present multiple independent variables in a line graph this way and put one independent variable on the x-axis, as this person has done, and then add multiple lines in the graph space to show the second independent variable. There are a lot of examples on Google if you do want to try your hand at it. When you create a figure, you must caption it. A caption is a concise but complete explanation of the figure. Type all figure captions with their numbers double-spaced below the graph. Just like tables, each figure should be on its own separate page in the Word document. In the figure's caption, always explain the units of measurement of the variables and/or the difference in levels of the independent variable. For example, figure 1, mean number of seconds taken for older and younger participants to identify the colors of colored words versus colored patches. Next, we have bar graphs, which are really useful for nominal data. So I imagine many of you will be using them. The frequencies for the different levels of the variable or variables or percentages proportions are represented by the height of the bar. You should be familiar with these from high school math classes. Some general tips when creating them are that bars should be easy to differentiate, so make them different colors or shading. 0 point is usually indicated on the vertical axis. Axes should be long enough to accommodate bar length, and conventional interval widths on the right-hand or the left-hand side, going along the y-axis there, are in 2s and 5s and 10s and 15s or in 20s. Of course, only choose one of these. If you only have a couple, or say if your dependent variable only ranges to 10, you might want to do interval widths of 2, but if it ranges all the way to 100, you'd probably want to do 10 or 20, depending on how your results were presented. And here's an example bar graph. Again, here you should note that you can present two independent variables at once with bar graphs. In this case, one of them is on a nominal scale, which is a major at university, either a psych major or another type of major. And one is on an interval scale, which is year of study seen on the x-axis, either second or third year. The dependent variable on the y-axis is a percentage which is on a ratio scale. Your bar graphs should look very similar to this one, with only two bars separated by a space if you only have one independent variable. One common mistake when using or making a bar graph is to exaggerate the size of an effect between conditions of a variable by not showing the full scale or quote unquote zooming in. Here you can see that salesperson 2 looks like they've sold a lot more than salesperson 1, but the increments on the y-axis are only in ones and they range from 96 to 100. So person 2 has only sold 2 more cars than person 1 when you really look at it, and they've sold 97 and 99 cars respectively, so they've pretty much sold the same number. Don't do this. Scatter plots are another choice of figure and are often used as a way of representing the bivariate continuous data you obtain in a correlational study, which I know many of you are doing. So consider creating a scatter plot if you have an ordinal, interval, or ratio dependent variable and a correlational design. A nominal variable wouldn't quite make sense here. Now for some final notes on visual data presentation. Remember, for any particular pattern of results, only one format should be used, table or figure. Try to make a figure if you can, but ultimately consider how your data pattern will be communicated most clearly and efficiently. You may include both a table and a figure if you wish to, but again, they must be presenting different aspects of your results. So you can't just show the exact same results in both a table and a figure. That's redundant, it clutters up your paper. Don't do that. On the flip side, you do need at least one table or a figure to fulfill the requirements for the next assignment, which we'll discuss at the end. And then you will also need to include it in your final research report. You want to focus on describing your pattern of results and whether or not they fit with your hypothesis. So make sure your figure or table helps out with this goal. And I'll say it just once more so I know everyone understands. One table or one figure per pattern of results, not both at the same time. As I mentioned at the start of the tutorial, your table or figure goes after the references section when you're inserting it into your final report. Each table or figure should be on a separate page at the very top, not in the middle. Each table and figure should be numbered and have a title which should be typed above the table or below the figure. So that's right, it is different for each type. Pay close attention. It's title above table, title below figure. And if you happen to include both a table and a figure, the table goes first and then the figure comes next. It's generally a very good idea to review APA formatting for tables and figures while creating them. And I've shown what they look like a little bit during this tutorial, but that is by no means enough to be an expert in making them. Remember, APA formatting requires incredible attention to detail, and you can't just do whatever you want to or what looks good. Every little bit of formatting is specified in advance. So please attend to this while making your tables and figures, as I will be marking table and figure formatting. And I've prepared a quick little guide to how to describe your results because I know it is pretty complex. So hopefully this will give you at least a place to start. First, you want to ask yourself, is your data nominal, ordinal, interval, or ratio? Once you decide that for both your independent and dependent variables, you want to ask yourself how you describe your data depending on what type of scale. So if it's nominal, then proportions and averages. ordinal, it's probably a median and not much else. And if you have an interval or ratio scale for your dependent variable, you would be reporting means, other measures of central tendency, and standard deviations. And then you can ask what tables or figures would be helpful depending on what type of scale data. So ideas here that I've already touched on a little bit in the tutorial. Nominal, consider a bar graph, especially if it's a nominal independent variable and an interval or ratio dependent variable. If you're reporting means and standard deviations, you could definitely do that in a table. And for a correlational study with independent and dependent variables that are at least ordinal, if not interval or ratio, consider a scatter plot because that could lend itself very well to that. So lastly, let's go over how to use Excel to obtain your descriptive statistical values. Feel free to revisit this part of the tutorial when you're actually doing your data analysis to see how to structure your equations in Excel. I know I was and I still am absolutely terrible at Excel formatting and equations, so I didn't even know half of these before I looked them up. So please refer back to it, use it. I'll also send these slides out at the same time as I send the simulated data out so that you have PDFs of the formulas to open and work from. Okay, so for the mean, you go to the cell right under the column you want to make an average of. It could work with a row as well, but mostly you usually use columns. You enter that formula into the bar above the spreadsheet, and then you would hit enter and there's your average. So you can see here that you've typed out the word average, and then you have D, which is your column, 1, which is your starting row in the example, and that's your starting row that you want to start taking the average from. And then you're putting a colon and your same row or same column, sorry, it's column D, and then ending row. So you're taking the average of column D, rows 1 to 50 in that example. These will all look quite similar. So for median, you do the exact same thing as the mean. If you were trying to take the median for column D, it would just be as simple as writing median instead of average. In the first part of the formula there, you hit enter and there's your median. Exact same thing for the mode. You go to the cell under the column you want to mode for. If you're taking the mode of column D, rows 1 to 50, you just type mode at the start of the equation, and then there's your mode. Exactly the same for standard deviation. And if nothing else, I would highly recommend you do it for standard deviation because it is a complex formula and it takes quite some time to do by hand. So you pay close attention. If you are taking the standard deviation of column A here, rows 1 to 15, you would type in STDEV.S at the start of your formula there. And otherwise, it's the exact same. Hit enter and there's your standard deviation. For your minimum and your maximum, those are quite similar to the previous formulas. You just do the same thing, but you put MIN for min and MAX for max. And then your range, you can just calculate that by hand because it is the maximum minus the minimum. So super simple, just subtraction there. For percentages, you can easily calculate this by hand too. Actual/possible times 100. We already talked about doing this. In more research-friendly terms, it's the subset of divided by the total, which is almost always your total number of participants, times 100. However, you can still use Excel for this. In the red circle there in the photo, you see how it says B2 divided by C2 with the equal sign before it. That will automatically generate a percentage from the two cells that you identify. So in that example, it's cell B2 and cell C2. Okay, so before we end, we have a couple housekeeping items. Assignment 8 was originally going to be the creation of a table or figure out of your own data, but it's been taking us TAs longer than we expected to track down all the information we need from each student if they didn't provide it well in their proposal, and to generate the data itself. So assignment 8 will still be due a week from today, but it will be quite simple. I'll talk about the instructions on the very next slide. I am in the midst of simulating your data and will have it emailed to each of you by this Friday afternoon. The major schedule revision is actually for your presentations. They will be pushed back 1 week, so you will present on July 28th, not next week. Next week, I will publish a short tutorial that will discuss instructions for your presentation and talk about writing a discussion section. And I will simultaneously be holding a very long drop-in office hour period from 8:30 to 12:30. So any students who wish to can come and discuss table or figure construction, how to analyze their data, or questions about the final research report. Feel free to book an appointment within the regular time slots, but I will also be on Zoom throughout the period for anyone who wants to drop in during a free slot. Then July 28th will be your last tutorial. We will be running the same live tutorial structure that day for student presentations of your project results that we did for the proposal presentations a couple weeks ago. Your assignment 9 and 10 marks will be combined and will be earned during your presentation by attending, presenting, and showing a table or figure and describing it, but a little bit more on that next week. And none of this shuffling will affect your final research report, which is still due on August 2nd at 11:59 p.m. And now for assignment 8's instructions. This is the entirety of the assignment and will be due 1 week from today at 8:30 a.m. PST. I don't think you should need more than 1 page to complete it thoroughly. So first, pick a study in your literature review that tests a hypothesis and identify a figure or table within that study that corresponds to the testing of the hypothesis within the study. So the variables specified in the study's hypothesis should be represented on the axes of the figure or column, column and row labels of the table. I'm just gonna. Okay. So pick a study in your literature review that tests a hypothesis and identify a figure or table that corresponds to the testing of the hypothesis in the study. So the variables specified within the study's hypothesis should be represented on the axes of the figure or in the column or row labels of the table that you're identifying. Then describe the figure that you have identified or table that you have identified, and generally in just a couple sentences, what results were supported, or what results from the study were supported. And then 1B, was the hypothesis in the study supported overall? Not just looking for a yes/no answer here, looking for just a couple sentences of context and what they found. And please include the full reference for the study you pick on a separate page or at the bottom of the page just somewhere, so I can find that study easily if I need to. And that is all for today. Thank you for bearing with me. I know it was long. Thanks for watching. And as a reminder, my drop-in hours are today from 10 to 11, and then next week for quite a long period of time, 8:30 to 12:30, July 21st. And have a great rest of your day.